All right, hello everyone, and welcome to the third Python workshop for the Python workshop series we have. My name is Jeffrey Duano.
And I'm your co-host, Marlene Salazar.
And today, for this workshop, we'll be going over while and for loops, different data collections in Python, importing modules, NumPy, and NumPy arrays.
Okay, so previously on our last workshop, we worked on the basic input and outputs in Python 3. We also learned about different data types and math operations and comparators. And then we created and used functions, and we learned about Boolean logic and conditions, if-else statements, and decision making. And I hope you guys were practicing on the Boolean logic I told you about. Okay, so for loops, we're going to start off with loops. And loops are used to repeat a certain task in a program until it is stopped through a condition. So there are two types of loops in Python that we are going to discuss. And one of them is a while loop. So a while loop is used when you want a loop to break after a condition. And then a for loop is used when you want a loop to break after a certain amount of times. So here we have some examples. A while loop is just like true, and for a for loop is just the amount of times. We'll go over them in the next slides.
Actually, I have an example here, but yeah, here's a few examples of the loops mentioned. Here's some while loops. So this loop will check if the distance is over 5. This one will go infinitely, printing these statements. This loop will count down a number x. And then for for loops, you got this one that increments loops in an array, which we'll go over later. And this one will calculate an average afterwards of an array.
Okay, so a while loop. So a while loop is a loop that iterates as long as it is giving a true. So it executes the code block under it as long as the Boolean expression is true. And then it also, just like how we mentioned in the last workshop, if it ends with a colon, then that tells the Python to start a new code of block. Then we indent, and that's the new code of block. And then we set the statements to run the program, then it jumps back to the start of the loop and it checks the condition again and again. And then this process either repeats until the condition isn't met or it repeats infinitely. And here's a basic usage of it. You literally write like while parentheses, and then within that, that's the condition that has to be true for it to execute.
To reiterate, the while loop keeps on looping until its condition is false. So this is how you would write a while loop. So you would have a while condition, the Boolean condition, something like x is the same as 5, or yeah, something like that. And then you have statements right underneath. So the while loop goes through these two steps. First step is it checks the condition. If the statement is true, the loop checks a condition and checks if it's true. If the statement is true, the statements within the loop run. If the statement is false, the statements within are skipped entirely, and the loop is finished running. So say we have a variable x equals 5. We initialize it. So while x is greater than 1, which is a condition, it checks a statement, and then it checks if it's first true. If it's not, this while loop would just be skipped. Like everything, statements below, first checks true since 5 is greater than 1. And then step 2, it runs through the statements. The loop then goes through all of the statements underneath. Like in functions and if-else statements, statements under a loop must be indented. Note that the condition will not be checked until all statements are run. So if we consider these two statements as a block underneath this while, these two statements will run like sequentially as they would in if-else functions in just regular lines. So we'll go through both of these. Then the while loop will repeat through these two steps until either the condition returns false or doesn't, which results in an infinite loop. So an infinite loop example would be this while true, and it's infinite because this condition will never be false, so it runs infinitely. So it'll keep on printing out this statement infinite loop runs infinitely. Next, we have for loops.
Okay, so a for loop, it is for all other kinds of looping, especially if there's a fixed or limited number of things to loop over. And it starts by initializing a variable that acts as an index or counter. In this example here, I is our index down here. And then the range or the amount of times you want to loop to run will be initialized at the same time as the index. And then we use the range parentheses function for integer ranges. And like the while loop, it then goes through the block of statements below if it's within the range. And then at the end of the statements, the loop goes back into the beginning and adds +1 to the index. And then this happens until the index is the same as the range and the loop breaks. And Jeffrey will show you.
Also, to reiterate, the for loop in practical use loops a certain amount of times. So this is how you would write a for loop. For index, in range, and then you have the statements below. So index is a variable used to denote the iteration of the current loop, like how many times it's already run. The index doesn't need to be initialized beforehand, but if you do, the index starts at the previously declared number. For if you're just starting out with this for loop, index will just start out as 0. So range, you have the maximum amount of times the loop runs. To have an integer be the range, you must use the range function. Like you can't just put in here for index in range 5. It'll return an error. So the for loop goes through these steps, which are similar to the while loop. Step 0, the initialization. The for loop initializes the index variable to 0 if index doesn't exist beforehand. So this becomes 0 if index doesn't exist. If the index variable exists, the index starts at whatever the variable was previously equals to. So say if you had index equals 3, it'll start at step 3. Then step 1, you check the condition. The loop first checks if the index is equal to the range. If index does not equal range, if it's below it, the statements within the loop run. If the index is exactly equal to the range, the statements within are skipped entirely and the loop is finished running. So if we're doing this for I in range 5, this I starts out as a 0. So, and then the range is 5. So as it goes on, it'll go from 0, 1, 2, 3, 4, 5. And then whenever it equals to 5, this loop ends. But during those iterations, you have step 2, which is where you run through the statements. Like the while loop, the statements under the loop, the for loop are run. There are no differences in the use of statements between the loop types. So again, it will just go sequentially, and at the end, it will go back to the top. The for loop repeats through step 1 and step 2 until the index equals the range, or in some cases, the index never equals range and the loop runs infinitely, which is hard to do with for loops in Python. In other languages, usually that may happen depending on how you increment or decrement the index. Now, there are some other features to loops that you may want to know.
So other loop nodes, there is a break. So like here in this example, the while is always true and it runs infinitely, but the break will make it go out of that loop immediately at the end of the loop. And then the continue statement, this will force the loop to go to the next iteration. And then the nested loop, you can also have loops inside of loops. So like an if-else blocks. And then a reminder using break and continue will only affect the loop that has the statement in its blocks. And then loops can be used in a conjunction with arrays,
which we'll go over later.
Yes.
So to elaborate, there's some notable statements that modify loops. You have the break statement, which will stop the innermost loop immediately, skipping over future iterations and statements. Here's an example. So you have this for loop, for x in range 10. So x will start out as 0, and then it'll iterate 10 times. And then inside of it, you have this if block, which checks if x is equal to 5. For the first five iterations, it'll skip over this block because it's not, x will not be equal to 5, and then it'll print the value of x. Once x equals to 5, it'll print out this statement, and then it'll issue the break, which then cancels out all the future iterations of this loop, and it'll immediately jump over to this line right here, which will then print loop finished. So if we demonstrate that, so for each iteration, it prints out 0, 1, 2, 3, 4, 5. Once it gets to 5, x equals 5, it stops this loop. And then it prints this, and then it breaks the loop, and then goes to the statement. Now, for the continue statement forces the loop to go to the next iteration, skipping over statements that would have been run in the current iteration. So, for example, you have this for loop that has an index starting at 0, and then it goes through 20 times. So at numbers, how it functions is at numbers 2 and 13 for the index, it'll skip over this statement right here, which for each iteration of the loop, it'll print out the index. But at 2 and 13, it'll skip the print, and the index will skip to 3 and then to 14. So if we were to show that, so you go through 0, then 1, whenever it equals 2, it skips over, and then go on through. You go 10, 11, 12, prints out all those, and then it finds this, index equals 13, skips over it, skips over this statement. And then it continues on until the loop is done. Then you also have nested loops. Just like with if-else statements, you can have loops within loops. Break and continue statements will only affect the innermost running loop. So say we have this example. It starts out with y equals 10. So you have this while loop, this outside while loop. This outside while loop will run infinitely unless you have something like a break statement. So inside that infinite while, you have this while, which checks y, which is 10 right now, and then it'll print, and then it will decrement y by 1. So this will keep on running. This inner loop will keep on running. This one will not go through any iterations until this loop is done. So once y equals to 5, because it's not greater than equals, it'll skip all of these, this loop breaks, and then it goes to this statement, which will print, and then it'll break this infinite outer loop. So it'll go pretty much nested loops, go inner loop, then outer loop whenever you want the inner loop to end. Now, going back to arrays.
Okay, so moving on from loops, arrays. So an array is a collection of data used to store multiple values under a single name. So it's kind of like a list, but it's different. So they can replace a set of multiple variables that all have that similar name and conventions and uses. And it just compresses them all into one line of code. And then Python has multiple ways to create data collections. Like I mentioned, it's like lists, tuples, and sets, and dictionaries. But today we'll go over arrays. And then we're going to use the module NumPy.
I think I have, oh, I guess not. Okay.
Okay, so why NumPy arrays? So NumPy is a numerical Python. That is what it stands for. And Python, it's like a Python library or module that allows you to create arrays and modify arrays with different functions that it has. So I don't know if you guys do like C++. When C++ it's like a header file. But anywho, here, so it is 50 times faster than the traditional Python list. Because if we use if you want to rename the module NumPy, oh, sorry. So it is faster than the traditional Python list. And then arrays are frequently used, especially in like data science, and it's like easier to use, and it's like way faster, and has like just a library of functions. And then, so how to use NumPy. So it's importing modules. This sets of steps shows you how to import NumPy and other modules. So at the beginning of your code, just like the header file, you put the line import NumPy. And then import is a keyword that imports a module, and then NumPy is the name of the library or the module you want to use. And it should be available in Colab. And if you want to rename the import file, you can always add, so as is a keyword to change the name of the module, and then NP is what we're naming it. So you can name it whatever you want. And this changes, instead of like typing the whole word NumPy, you can just type in whatever you named that module. And then to use the NumPy function, you do the np.function array, and there's different functions within this module, and we'll show you them later on. And then np is the name of that you set beforehand. If not, it's just NumPy. And then here we just have an example of renaming the NumPy module.
Even though that was pretty extensive, to reiterate again.
Yeah.
For this workshop, we are using NumPy. NumPy is a module that adds in arrays and array functions to Python. To import any module, do the following early in your code. For most uses, you would want to put this in the beginning of your code, the beginning of your file. So import is a keyword for importing a module. Module is the name of the module. Like, you're gonna have to look up what module you want to use. Like if you're using NumPy, if you're using OpenCV, TensorFlow, any other module that you can find, especially on Colab. And then you have as mod. It's optional. If you want to change the name of the module, mod is the name of the module, change to whatever you want. To use a module and its functions, you have this mod.function. So mod is the name that you chose, either if you changed it or you have the original name of the module imported earlier. And then you have the function, which is any function within this module that you imported. So some examples, you have import sys as system. So you can decide, if you really want to, you can lengthen the name of a module. Import NumPy as NP, which is what we're going to be using for the rest of the workshop when we go into arrays. And then import CV2 as CV. This line will import the OpenCV module.
Okay, so to create a NumPy array, you use the array function. So from the NumPy module, from the NumPy module. So basic usage, here we have array name. You can name this whatever you want to give your array name. And then equals NP. This is like before we said, the NP is the name of the NumPy that we renamed. And then the dot array is a function we're using. And then within the array, we use 1, 2, 3, 4, 5. And that is our array right here. And then you can put any amount of elements into the array as long as they're all the same data type, and you have to separate them by commas as well.
Again, reiterating, NumPy arrays are created using the array function from NumPy. The syntax was explained earlier, but array name of array, it uses the same variable naming rules, function naming rules. NP or NumPy, depending on if you want to remove this. Array is the function that creates the array, and then everything within the brackets are the elements of the array. You can use any basic data type. For here we have integers, but you can change that to something like, you could change that into, I guess, string type, float type, which would be decimals, and etc. Each element is separated by a comma. So here's some array examples. So you have this one, which is an array of strings called fruits. So you have fruits, the name of the array, go through the np.array, and then you have this within the brackets, you have the elements, apple, cherry, banana. And then for this one, you have float values, which are decimals, double, yeah. you have this array called decimals to 1, which is initialized by the np.array, and then you have the elements going from 0.1 to, it'll continue on to 1.0. But yeah, you can have different types within your array. But you can only have the same type. Say you can't do something like apple, then 1, then banana. You can't do that. You have to have the same exact data type for your array in all elements. So to use them.
So to access the NumPy arrays, there is a function for that. Use the array name and the index of the element you want to see. And arrays element indexes start at 0 and not 1. So like if you start your array with 1, 2, 3, 4, 5, those are just the components within it. But the index is where it's located, and it starts with 0, 1, 2, 3 all the way. And you can read or modify array elements as if they were variables. And here we have an example of the basic usage. Array in I is where the index of the element you want to access. So see your array here and the index is totally different from what's in it. So here we printed out what the array has and the index 0.
So to access an element within an array, use the following notation: array with brackets I. Array is the array name, I is the array element index. The index is started at 0, not at 1. So here's an example. So you have an array of strings, which say the directions, up, down, left, right. So this, well, element up is at index 0, down is at index 1, this is at 2, this is at 3, instead of it starting at 1, 2, 3, 4. You can use elements of an array as if they were variables. This following example uses the elements of student scores to find and print a total, an average, and the first element. So you start out by creating this array called student scores, which has the 3 elements, the 3 integer elements, 90, 92, and 82. Then you have a variable called total, which uses these elements, which you denote as student scores 0, which is this one, this 90. Student scores 1, this is 92. Student scores 2, which is 82. And then average, you can use that to create the average. And then this will print out total class score, average score, and this first score, student scores 0, which would be 90. So if we were to do that, so total class score, all of these would add up to 264. Average score would end up being 88, and then the first score, 90. So you can also modify elements within an array. This example shows how the second element, or index 1, of the array is changed. So you have this first array called names, which has the elements that are strings, Kara, Will, Alice, and Bruce. So right here, we're modifying the second element, or index 1, which is Will. So before name change, this will print out the original value, Will. But you can modify it by doing this, names brackets 1, which will change this into Bob. And then whenever you print that out, it should print out the new value, Bob. So if we test that out, before name change, Will, after name change, Bob. Yeah. Another use of arrays is with loops.
Okay, so if you want to go through an entire array without using too many lines, you can always put it in within a for loop. And this can be used for user inputting elements, outputting elements one at a time, and searching and sorting, and there's like many more. Basic usage. So you put for I in array, and there's no need for a range function. With this one, it's just the np.array and then the ARA.
To elaborate, you can use loops to easily access elements within an array. So for this example, this entire block, we will be using the array. So it'll count from 0 to 7. That'll be eight elements, And to make it easier, all of these are ordered like their index. So if we were to try to print out each element of the array, you can do two methods. Using the above array, compare the two blocks of code that print out all elements of the array. So without a loop, you would have something like this, where you would print out each array element individually, and it's just a large block. This is 8 lines of code that are potentially wasted. So with a loop, you can do for I in array, and then you could just print array I. Since I will change during this for loop, it will increment from 0 to how many elements are here, 8, and then it'll go through each element and print them out in only 2 lines. And then another example involving adding 1 to even elements of an array. So this one you have, for this array, you would be modifying to the even indexes, even elements, even indexes, just to make sure. So here, if you're doing that without a loop, you would have multiple lines modifying array 0, 2, 4, 6, and then you would print the array. But then this, with one less line, you could do for I in array, if I mod 2, basically whenever you do mod 2, it'll bring a remainder. So if you have 0, 2 mod 2, right? That will leave a remainder of nothing. So that would be 0. That would be the odd numbers. That's a way to that's a way to get odd numbers. Check odd and even numbers. Yeah. Anyways, so whenever you do this if block, it'll increment the even indexes by 1. And then after all of that, you print the array, and all of the array elements should be modified.
So there's more NumPy functions. Like I mentioned before, NumPy includes a whole lot more functions within the Python library. And then, there's also like array name.copy. This copies an entire array to another new array. Name view, this creates an array that only views an original array. And then also modifies done to view affect the original one, and vice versa. And then the concatenate, it just basically puts them together, array first and then the array second, and Jeffrey will show you that.
Right. So yeah, there are multiple functions that we'll show right now. So you have copy, which copies the contents of one array to another uninitialized array. Modifications to the copied array do not affect the original. So you use it like, say you have this array right here, or if you have an old array called old array, you can make a new array that copies the contents of this array, old array, into new array. So this, to show that, this example prints the original and copy, modifies the copy, then prints both again. So starting out, you have new array 1, which copies array 1 up here, which would be 0, 1, 2, 3, 4. So whenever you print these out, you would get the same array. So for this one, for here, it then increments each element in this new array, which has the elements of this. So basically all of these will be added up by 1. But whenever you do this, it does not modify the original array 1. So whenever you print that out, original 1, array 1 will not be modified, but this one will be. So if you test that out, down here, you have original 1, which is array 1, and then copy unmodified 1, which is new array. So whenever you print those out, the new array will copy the elements of array 1. But then after the modification, you would print out the original, which is unmodified, from this block right here, But then you would also print out the new array, which is modified. So the next function we have is view, which creates a new array that views the values of an original array. Changes done to the view affect the original and vice versa. If you know them, they're basically like pointers, and if you know C, they're basically pointers to arrays. So basic usage would be just like the above, except you change this to view. This example is similar to the above with some differences. So using array2 for this, new array2 equals array2.view. So basically it makes a new array called new array2, which checks the values of array2. So just like the above, we're going to do new array2 shows that we'll print out the original array2, and then we'll print out the view, which should be the same. But then this line modifies an element within new array2, which then modifies the original. So whenever we print these out, it should change the last element 9 to 10. For some reason it has the spacing error, but don't mind that. But yeah, it changes in both from 9 to 10. And then one more function would be concatenate, which creates a new array that combines two arrays one after the other. You use it like this: new array equals np.concatenate, and then within parentheses or brackets, you do the first array you want to show first, then you do the second. Array 1 will show before array 2. So say you had this new array called final array, you concatenate it 1 and 2, which doesn't affect these two, but it will make a new array called final array. So whenever we print that out, it'll have all of the elements from array 1 and array 2, even after it was modified here. After that, we have some more functions that we can show you.
Yes, and those more functions include the split, where it splits an array by the n parts and then returns an array of arrays. And then the np where, and then the array name equals n. That one is search an array for a certain value. And of course, if you're using letters instead of numbers, you would do the quotations instead of, and like around the n, instead of like numbers where it's just a number. And then the np sort, this one just sorts an array in ascending order.
To elaborate, for these examples, we will be using array 1, which has the elements 0, 1, 2, 3, 4. Array split splits an array into multiple parts, returning an array of arrays. You'll see what I mean. But the basic usage is if you split the array, you do new array equals np.array underscore split, and then you do the old array that you want to split up, and then n, which would be the n number of parts that you want the array to be split into. So new array would be np.array split underscore split array 1, 2. So it splits this array right here by 2. Even though this is an odd number of elements, it'll still split it, unlike other functions in NumPy, which would return an error. So whenever you print this new array that's split up, it'll show the array of arrays. So you have this one, this first split, which is 0, 1, 2, and then you have the second split, which is 3 and 4. Now the next function is where, which searches an array for an element. The function returns an array of indexes where an element n was found. So you use it, searched will be an array. You do np.where, and then you have a condition, a Boolean condition right here. Say if you're looking for the number 4 right here, or if you're looking for a character, a string in an array, doesn't matter. You would have to do the array you want to search for equals the element you want to find. So here you have this array, this new array called searched, which whenever you do np.where, it searches this array, array1, or this one up here, and it searches for the number 4. And then it'll print, here we'll have the locations where 4 was found, or print, and the array that you get from this np.where would be location 4, which is right here. Final functions we have is the sort function, which sorts an array in ascending order. The sort function defaults to using a quick sort, but you can change it to different sorting methods like merge sort, bubble sort. Sort returns the sorted array, but leaves the original intact. So say you have this jumbled up array called this array. You have the elements 5, 2, 6, 9, 3, and 2 in that order. So if you do this, you make a new array, which is sorted. You do np.sort, and then you sort the array you want sorted inside the parentheses. So it doesn't affect this original array because it makes its own new array right here. So if we were to print both of them out, you would still have this 5, 2, 6, and so on for this array. But then you have the new sorted array 2, 2, 3, 5, 6, 9, which is these elements sorted. Pretty much now we have a couple of challenges for y'all to consider trying to do with the stuff you've learned from this workshop and the past few workshops. Challenge 1, we have you write a function called moving forward that prints out no object detected moving forward. You want to create a program that prompts the user for a variable named distance. Then write a continuous loop where every loop iteration decreases the distance variable by 1. As long as the distance is greater than or equal to 10, it will call the function moving forward. Otherwise, it will print the error object detected, movement stopped, and break the loop. Now the second challenge we have is write a program that helps teachers and students find the average of the grades. Prompt the user to give the number of grades, then create an array of size grades and go through it, prompting the user to input each individual grade. Then compute and print the average. A couple of hints: you need to go through the array once more and add up all the values before calculating the average. Another hint, you also need to use this function right here, np.empty, to create an empty array that has the size equal to the number of grades. And with that, that is it for this week's Python workshop. And I hope you all have a good day.